Good afternoon, everybody, and welcome to this 10th edition of TKI Wind Op Zee Live. My name is Sophie van Hoytema, and I will be your host for the next hour. Last edition, we saw GBM Works and Jungle win the Offshore Wind Innovators Award, and this time we'll talk about something else. With me in the studio again is Director of TKI Wind Op Zee, Bob Meijer. Welcome, Bob. What are we going to talk about today?
Yeah, today we have a very interesting topic, I must say. The question is whether we've reached the maximum size of offshore wind turbines.
So maximum size of wind turbines. Don't we always need bigger turbines to yield more energy?
Yeah, that was definitely the case over the last years. With ever larger turbines, more energy at lower cost. And the question is whether this can continue, technically, but also financially, whether it's maybe more advantageous to standardize. So that's the question we're going to answer today.
Very interesting subject. Thank you, Bob. Let's start by asking you, the audience, what your view is on the matter. So it's kind of interactive. We'll be using Mentimeter. On your screen are now the instructions on how to participate. So please go to menti.com and insert the code 1638420. You can do that right now. So you can answer the next question. Should we standardize offshore wind turbine sizes? So that's the question, and the answer will be either yes or it will be no. So please, the menti.com and insert the code 1638420, and then you can answer the question. Very good. Very interesting today. In the meantime, I'll tell you what's in store for this edition of TKI Wind Op Zee Live. And of course, welcome our other guests at the table here. First of all, a warm welcome to you, David Molenaar, CEO of Siemens Gamesa. Welcome.
Thank you, Sophie.
You'll join us to give us your view on the need of standardization. So we'll look forward to that. Thank you. And then, of course, we have Wouter Dirks van Oord. Welcome. Your company is an important service provider for the offshore wind industry. And it remains, I think, to be seen if the maritime industry is an advocate for standardization, isn't it? We'll see about that.
Yeah.
We'll talk about that later.
Talk about it. Yeah.
And then, of course, we have Mark Collier here. Warm welcome to you, bird ecologist at Bureau Waardenburg. And you'll shine your light on the ecological effects of the size of wind turbines, especially, of course, for birds and bats at sea. Welcome.
Thanks, great to be here.
Yes, thank you. So let's see if we have some results of Mentimeter. Where can we see that? Are there any results? Yes, okay, so a big yes, I think. 82%, if my eyes are still good. Should we standardize? Bob, what do you think about that?
A striking result, I must say. A couple of weeks ago with the Q meeting that was organized by Siemens Gamesa and Van Oord at the TU Delft, the same question was raised. And it ended up with 50-50, but only after a short debate about that. Initially, it was the other way around. So I think this is a striking result that many people are in favor of standardizing the size of offshore wind turbines.
So maybe they listened very well and they thought...
That could very well be the case. Or they also may have read the very interesting report of DNV that was commissioned.
We are going to talk about later on. Are there any reactions? What do you think about this result? Well, it's going a bit down right now, 87%, but still very high.
Still voting. Still
yeah. What do you think about that?
Yeah, I think
Wouter?
The view we have is that larger turbines still for many years to come will reduce the levelized cost of energy. And if that's what society needs, then increasing turbine sizes makes sense. Mm-hmm. But there's also, of course, all kind of backsides there. All kind of environmental impacts, larger turbines, larger rotors, maybe for the birds not good. Larger turbines means a larger foundation, needs a larger hammer, means more noise. So if it is better for our planet to go for the biggest turbine, I'm in doubt.
Yes, I
Yeah.
think Mark will give his view on that maybe later on also. But what and David, can I ask you what you think about this this result of this question that the people in the audience think yes, standardization.
Actually, I'm quite happy because indeed what you said is that on the Q meeting we started with a question before and after Jan's presentation. And before it was to a large extent people were against. After his discussion and in this great example about the A380, it was 50-50. Actually, it was one vote in advance of a yes.
Yeah.
And now it is striking 80-20. I think it's a marvelous result. So I hope that we can also debate how to realize that.
Yeah.
Because that's, I think, the next step.
Very interesting. So I can imagine that the audience, you at home, might have some questions during this webinar. And so if you do, please ask them via the chat or on the comments on LinkedIn. And of course, we will try to answer those questions during this hour. If not, we'll definitely get back to you to answer those questions. Let's start with this report, with the research conducted by DNV for TKI Wind Op Zee and the Netherlands Enterprise Agency on the optimal wind turbine size. And welcome Tamara Doria. She's joining us online. Welcome. I can see you right now. Very good. You are a specialist on renewable energy at DNV and took part in writing this report. And you have two colleagues with you today here to answer the questions that require more specialist knowledge. Very difficult word. So welcome to you also, Lars Valbe Hansen, and of course, Ben Chilvers. Thank you for being here. All three of you, of course. Maybe you can wave a little so we actually know you can hear me. Yes, there you are. Very good. Tamara, may I invite you to share your conclusions and the most pressing questions regarding the optimal wind turbine size. Go ahead.
Okay. Thank you very much. Thank you for allowing us to be here. It's really nice being able to present this study to such an interesting public. We were asked by RVO to conduct a study on optimal offshore wind turbine size and standardization. And I'm just going to talk about our findings and what we did actually. I'm going to start with a quick introduction into DNV for those who don't know us, the project team, the background, so the questions that we were trying to answer. And then the study was twofold. So we started with a numerical study where we used our in-house software, Renewables Architect, where we really tried to get some data, try to work out what the lowest cost option is. And then we also gathered all our experts and really investigated for all the different components that are important for wind turbines and wind farms. So looked into technology, manufacturing and standardization. And finally, the conclusions that we came up with. So quickly about DNV, we're an independent insurance and risk management company with many years of experience in lots of different countries. Originally, it's a maritime classification society, but right now we operate in many different industry, like energy, assurance, and we've got quite a lot of software and digital as well. And this work was done by the energy advisory part, and more specifically the renewables energy advisory part, which has decades of experience in wind energy. So we could really draw on a lot of experience here. As you said before, Ben and Lars are with me, so I'm part of the numerical cost analysis team, and there were quite a few experts for O&M and the electrical part, installation, manufacturing. So we put all of our heads together and really try to look into the details and try to see what we think will happen. Coming to the questions that we were asked to answer. So the main question was, where will the growth of turbine size and power rating continue to what will constrain it, will it end, and where, and what will be the barriers there. And then the second big question was, is there any potential for standardization and industrialization? And is any of that happening already? And yeah, what's the potential? What could happen? We broke this down further then into a few objectives. And as I said before, we started with a numerical analysis, really looking at the viability of offshore wind energy and the whole farms. And we looked at 3 different scenarios for 3 different years, 2020, 30, and 40, just to see if the optimal turbine size will change. Then we looked at showstoppers, so barriers to growth. We looked at the impact on supply chain, the potential for standardization, what will happen with economies of scale. And finally, we put all of that together, all of our analyses and investigations, and came up with a conclusion. So to start off with the numerical part of this study, I'm going to quickly introduce the software that we used. So it's called Renewables Architect, and it's an advanced design and cost modeling tool, which has grown over the years that we've been doing wind energy. And we've got engineering models for every turbine component. So you can see the blade there, we've got a tower model, we've got a nacelle model, and all of these are engineering models where we calculate the cost by doing some preliminary design based on engineering principles and engineering calculations. So we need some headline parameters as an input, like the turbine rating, hub height, diameter. Then we do a loads prediction that we are basing on another DNV tool called Bladed. And finally, we design all of these components, price them up, and then put them all together, and then can put a price tag on a final turbine. The next part of Renewables Architect is everything that comes after the turbine, because of course a wind farm does not only consist of the turbine cost. So we need the balance of plant cost, the electricals, we need the energy production, of course OPEX costs, and then finally it all needs to go through an economic model where we calculate the levelized cost of energy. And I think you've mentioned before, levelized cost of energy is assumed as the main metric to explore future turbine feasibility. So all of that is in Renewables Architect. And for the O&M cost, we supplied additional information from another DNV tool called O2M, which is really drawing on all of DNV's operations expertise, because it's deciding on a strategy, what vessels to use, what strategy to use to achieve lowest OPEX cost. So all of this together leads us to the levelized cost of energy. The inputs we used for this study are based on a site off the Dutch coast. It's fairly low water depth, relatively far from port. We looked at 2 mean annual wind speeds, and we set a fixed farm capacity at 1 gigawatt. And then, as we have that fixed as the site conditions, we wanted to explore all the different turbines that would be possible. So we ran more than 8,000 runs with turbine ratings from 12 to 30 megawatt. And we also ran different turbine diameters. So there's a relation from rating to turbine diameter with a specific power density. So for each of these ratings, we ran a variety of diameters. We looked at 2 different drivetrains, different tip speed ratios, and we fixed our lifetime, because that's a different study to look at the effect of lifetime. And we then set distinct cost learning and load reduction factors for our 3 scenarios, 2020, 30, and 40, where we're already assuming that certain components and certain things will, due to technological advancements and to because of economies of scale, will get cheaper and loads will be reduced. So we set a number of factors to to model these scenarios, really. Coming up to our first results. So in the plot on the right, you can see the red dotted line, that's the cost of energy. And as you see, it's very, very flat. We could not really find any minimum. There's a slight uptick towards larger turbines when it gets towards 30 megawatt. But generally, the cost of energy is relatively flat for all turbine sizes. What we found is that there's an increased cost per megawatt for the turbine supply, as well as for the foundations. So we modeled a monopile in the study. And then the question is, why is the overall cost of energy still constant? And the answer for that is the OPEX cost. So the blue line in the middle shows how the OPEX cost is decreasing with larger turbine ratings. And because that is an annual cost, which is every year over and over again, it adds up. So that's the balancing factor against the CapEx. And this is why the cost of energy that we come up with is relatively flat in the end. If we then look at the different scenarios that we modeled, so the top line here is 2020, the bottom line is 2040, we can really see that all these assumed cost reduction and industry learnings, they lead to quite a significant cost reduction. And the cost reduction that we can achieve with these industry learnings and standardization is a lot more significant than anything that we can achieve by varying the size of turbines. So this is really a strong point for standardization and focusing really on making every component and everything cheaper rather than growing. Another finding that is not shown in this graph, but we found quite interesting, is that the higher the turbine rating and the higher the optimal specific power density, that means that the optimum turbine will have relatively short rotor blades and a relatively large generator power. So that means that growing the rotor really comes at a really high cost. The findings of these numerical studies are then that we are assuming a reasonable increase towards 2030 in rated power, up to maybe 17 to 24 megawatt range. We are only expecting a limited increase in rotor diameter, though, maybe up to 265 meters. And what we really expect to see is that we're going to have highly cost-optimized turbines, which will feature many new technologies, and they will be operated and maintained following new strategies to really bring down that OPEX cost, because it's such a relevant factor. And then it needs to be said, because in this study we did quite a lot of sensitivity analyses, and we really saw that the optimal turbine design, especially going for these large turbines, will be highly dependent on the site conditions and the turbine design choices and the OPEX assumptions. So it might be that if we look at an entirely different site, we might have different conclusions. Coming to our qualitative part of this study, where we looked at the past, looked at what we see in the industry and what we are expecting to happen. We looked at all the different components, and we see no hard technical limit to design and manufacturing these larger parts. We see some soft limits for high capacity pitch bearings and gearboxes, but we've seen similar obstacles in the past where materials were short of supply or certain subcomponents were hard to get by. But the supply chain has always adapted, and there's been technology that has been able to deal with this. So we are expecting this to happen again. So we see no hard limits here. in terms of standardization and increasing production numbers, we really see how that has a very high potential to reduce the turbine cost. And we also see a large potential for this standardization, especially in the supply chain of components. So in our report, we go into every component and look at that in a bit more detail. But we can really say that the continuous growth of turbine platforms has generally prevented standardization. There is some parts, especially where we've got overlap with other industries, or maybe smaller parts where we see standardization, but we believe that there's a lot of potential and that will bring down the costs. This leads me to the main findings and conclusions. So we do believe that the rapid growth in offshore turbine size is expected to slow down. We do not see any main hard technical barriers that limit the further growth, but our numerical analysis indicates that the LCOE won't go down by growing much further. And then we really need to say that if we are focusing more on CO2 impact and if raw material prices continue to increase, the balance might be tipped towards smaller turbines. That's everything I had to say. Thank you very much, and I'm very curious about all your comments and the discussion.
So thank you very much, Tamara. I think I'm very curious. Thank you very much. But I'm very curious if there are any questions of the audience.
Yeah, definitely. There are some questions. And can we ask them now?
Of course.
Yeah? Okay. Yeah. A question from IJzer de Vries is about which types of wind turbines you've modeled. Is that only one type? So, for example, a direct drive or a geared, or did you have various options?
We had two different options. So it was direct drive and geared. The results weren't massively different, and it was a monopile turbine in a 30-meter water depth. So that is relatively specific, yeah.
Thank you for answering that. I hope that's sufficient answer for IJzer. There was also a question about assumptions about the offshore substation. Was that part of the LCOE calculations?
No, we cut out the offshore substation, so all the LCOE numbers are really only up to all of the electrical infrastructure up until the substation, just because we set it at 1 gigawatt and it will be the same for all of them. So we left that out of our assumptions.
Okay, thanks. But at least that explains the baseline number for the LCOE that you've used. There was also a question about more about the introduction that we had. That at the TU we had the Technical University of Delft, who had this discussion about the maximum size and not so much about standardization. I think it's an interesting remark, although I think that if you talk about maximization, if you start maximizing, then the flip side of that same coin is, of course, that you start working on standardization. So if it's one size, then... but in fact, I think that was right. The discussion there was more about the maximum size that was achievable. And learning from DNV, there are no, say, technical limitations to further grow wind turbines, but the limitations really come from the economics. Yeah.
Yep. Are there any questions at the table at this moment?
Yes, I may ask, may I ask, is the if you extend the lifetime by 5 years, what would be then the impact? And is that the impact bigger than a change in rotor diameter of turbine size? At least, did you study the sensitivity towards lifetime extension?
That's a really interesting question, and it's part of another study that we did for RVO. So we really kept it constant for this study. And I'm not sure what RVO's plan is on publishing this other study.
Because you showed a graph where you could see the cost increase or decrease depending on the component you took. If you can show that graph again about the transport and installation cost and the electricity cost of the infrastructure, if you can put it on the screen. that's possible.
Tamara's
I guess-
working on it. Yeah.
Was it this one?
Yeah, this one indeed. And especially because if you also standardize, you say you maximum your rotor diameter, you also maximum your power output. That also means that on the electrical infrastructure, you can even gain more by extending the lifetime of your infrastructure as well. And also, maybe the single turbine, as you predict, can be more expensive, but overall, it's more effective because you can also differentiate between the lifetime of your electrical infrastructure and your foundation infrastructure and your turbine infrastructure.
Oh, so you can start reusing that same electrical infrastructure for a much longer time.
Yeah.
Interesting, yeah, absolutely.
And that saves decommissioning costs, that saves also material use, and I think that's quite effective to focus on standardization of your rotor, and especially that will bring more benefit, but also makes it possible to extend the lifetime as well.
Yeah, interesting.
So we already started, I think, with the discussion here at the table, which is very good. So thank you, Tamara. Please stay put, because maybe we have some questions for you and for Lars and for Ben, of course. I wanted to ask you, David, what your first response was to the report of DNV, but I think you already... But is there another response to this report?
No, I'm very pleased, but also to learn. I mean, it's also, if you look at it from a risk perspective, you have either two options. Either you continue your race against in developing and designing bigger turbines in the hope that it will bring benefit to lower cost, or you can take the next turn and focus on industrialization, which by sure will bring you a cost reduction and potentially also bring a double benefit to reduce the societal impact, but also maybe the environmental impact. So I think if you have two options, either left or right, and by going left, you are not sure if it will bring the benefit you want to achieve, and taking the right turn, you are really guaranteed of having that impact. So that's why my preference is to go to the right, to make sure that you really can gain the benefits you need to be gained.
Yeah, so it's a plea for standardization. Yeah, of course. Wouter?
Yeah, the question I have, David, is standardization is you can standardize everything. That takes away certain options to optimize also. So, for example, standardization of the foundation in the North Sea we've got monopiles, but still every single monopile is different. It's custom designed for a single turbine, site-specific. So we don't standardize that. I say we do the engineering effort to bring that cost down. So that's an example where standardization to a certain level works, but...
No, but we must continue to do that.
Yeah.
That's for sure.
And my question is, where is it? If we look at the balance of plant cost, that keeps on going down if you continue to increase monopile size. So our conclusions are a bit different from what DNV is concluding. So it must be in the turbine, I think, where you have to do it, the standardization, I guess, rather than in the infrastructure.
Yes, and I think my main focus was being, at least what my plea is, to fix the tip height. And if you're fixing the tip height, you're fixing your lower tip height as well. So you have a fixed rotor diameter, and that means that you have a fixed power output and a fixed loading on your infrastructure. Meaning that you can design your supporting structure and with a different lifetime than your design of your electrical infrastructure. But also you start optimizing your system. And I fully agree, monopile design will be fully site-specific, locally based, but it is easy to be done. But if you can standardize the nacelle, the rotor, the components, we can start making more speed, because essentially, if you install one turbine or two turbines, you can do it with the same vessel, you can continue to install. If you don't reach the maximum tip height, then you can just make speed. And I think what we have to do, we have reached the zero subsidy level. We have to make more speed, because we have to install in 3 years' time, from 27 to 2030, 1,000 turbines, so one a day, at least for the Dutch part of the North Sea. So we have to make speed. Yeah. And you can only make speed when it is in your product.
Thanks for that. Let's listen to Mark for a second, because of course, what is the impact of these constant bigger wind turbines for sea life, like birds and bats? What's in your view on that?
If you look at the two of the main impacts for wildlife from offshore turbines is collisions. So that has a very obvious effect. So birds collide, bats collide, and they die. The other is displacement, and that is from local birds that would use that area of sea for feeding or resting, and they can perhaps be moved out of that area by sort of being scared, if you like, from the presence of the turbines. If we take the first collisions, I've heard it suggested already, but there is an effect from the size of turbines. If we're limiting the output of a plant wind farm, then it's actually better to have fewer but larger turbines rather than many smaller turbines. What it is we use models to calculate, and based on data from onshore, calibrate these models, and we can calculate the risk of collision. And a risk of collision from a single bird flying through a turbine is lower for a larger turbine than a smaller turbine.
That's interesting.
On the other side of that, you have a larger turbine has a larger area swept by the rotors, where potentially more birds could fly through. But what we find is that the density of birds in that air layer decreases with increasing height. So once we get to above 30, 35 meters, the numbers of birds and also for bats decreases. So if you're having larger turbines, the highest risk area is close to the hub because the rotors are wider and the chance of avoiding going between the rotors is lower. If that hub height, where the highest risk is actually higher, then the risk is lower because most of the birds are passing through the lowest part of the rotor. Better still, and this has also been suggested, is actually place the rotors higher. But that obviously has a cost for yourselves on sort of structure and more sort of, yeah. But for birds, it is a benefit to place the rotors higher and to have fewer but larger turbines.
Interesting view, I think, again.
Making it not
it doesn't make it easier. I don't think so, too. So, Bob, do you think the industry is ready for standardization?
Well, you hear the industry talking about this, and I think this report is quite new. I think also the insights are maybe new, at least presented in a new way. I really like the analysis where you can see, for example, the balance of plant cost that could still go down, and the OPEX cost could still go down, but the turbine cost will go up. I think from purely this economic analysis, there is kind of an inevitable conclusion. So it's more the question, how are we going to standardize, but not if we're going to standardize. But then these other effects come in, so the ecological effects. And possibly there is a certain extra effort that we need to take to be able also to have a positive contribution to the ecology in that way. And maybe higher hub heights are a solution to this. And I understand that, say, the 35 meter is an important, say, boundary, as you suggested, I think. And below that, there are way more birds, and above that, much less.
Yeah, that's a general figure, but if you're thinking around 30, 35 meters, then numbers do decrease.
Yeah. So I can already imagine that there are rotors possible, specifically if you start standardizing on a certain size, that can fit well between the maximum height and this lowest tip height.
Still taking that into account.
To take that into account, I think it's a very relevant factor. There's also other positive effects, I would say, of standardization or maximization in a way. As Wouter already mentioned, like the monopiles, of course, we've all converged to this one solution, but it's not completely standardized. But we've seen them grow quite considerably over time, and that also requires ever-enlarging vessels and cranes, but also hammers to install them. So maybe in the reduction of piling noise, this could also contribute in a way. Still, you would have to install maybe more of them. So all these trade-offs, if it comes to ecology, I think still need to be investigated.
And I think if indeed if we would sort of limit the maximum size, the investments in innovation would go to completely other subjects than just investing in the larger crane, the new gearbox, or you don't have the gearbox, but the generator. But and into
that's a fair point.
Yeah, and
especially we can look into a design with let's say nature inclusive design, so that you not only look at from an economic perspective or a power output perspective, but also from the we do have a North Sea. It's a unique opportunity that we can use in a way. It also brings benefit to the fishery, but also to the environment. And at the same time, we need to design to become circular. So we have to shift our focus from lowest cost, which we have achieved. I think is beneficial. Now to how to benefit from this beautiful North Sea, where we can have a combined breeding ground for birds, but also for the fish, and at the same time design for circularity.
Yeah. In what way does not having any standardization harm the wind industry at this moment, you think?
Now, I think that everybody is so focused on their own individual business case that each individual business case is attractive. But if you combine it, the total case is non-optimal, and nobody is forced to take the step to design for circularity, for example. If we have designed circular blades, which are a little bit more expensive than a normal blade. So if you only select on lowest cost, they will never be implemented.
It's the only incentive there is at the moment. Yeah?
So what we have to do is to have, let's say, the government defining the level playing field and challenge the industry to become circular, to become nature inclusive, to become... So this step we have to take.
Yeah.
So force the industry, but challenge them to make it happen.
Yeah, I agree with that. And I think also there's so much room for further, say, innovation also in standardization itself. So once we've converged to a certain size, there's a whole wealth of options that we can still further develop to bring costs down even further and deeper. But also to improve on ecology. For example, with new installation methods. And we've seen developments in say, different installation methods over the last, 20 years. But not all of them have reached, say, the finish line of new products on the market. And one of the reasons was that they were always fighting to get the next level of XL monopiles installed, also with this new technology. And so all these innovations never came to fruition because they couldn't keep up in a way with the ever-growing monopiles that they had to hammer in a way or vibrate in. And so I think it also provides more room for new innovations in terms of transport, installation.
One thing I heard Tamara also say, so it's very dependent on the site you're looking at. If we look at an international way, what would standardization in the EU or in the Netherlands mean for the competitive position for your company, for example?
It's a very good question. Developers and countries in the other side of the world may have a completely other perception of what's relevant. So, and if we invest in a new vessel to install turbines, we will not just invest for a vessel that can do it in the Netherlands with maybe a limited turbine size. It also needs to be deployed maybe in the US or in Japan or wherever. And if the development there is towards bigger turbines, then we still need to invest in this larger turbine. So a local regulation is not really helpful for making a more sensible
can imagine
decision on your investment. And I can imagine that maybe for turbine suppliers or OEMs, it's maybe the same.
It's a sensitive discussion, but if you look to the total market until 2030, the global market is around 140 gigawatts. The European market is around 80, and the Dutch market 15. So meaning that the Dutch market is around 15 out of 80 is about 16% of the market. So it
would be a nice start.
It's a nice start. Yeah. And I think in terms of beating climate change, in setting the tone, should we wait? Or shall we take the lead? And I think this is also a point when I look to our minister. Do you want to be leading in this role, or would you be lagging? And I think that's important to understand. If you may take the lead, you can also show the road to a sustainable future.
Well, I think there's a lot of discussion still to be done. But first of all, we're going to do something else because, well, we can talk about this. We're going to do that later on still. But we talk about, is the industry ready for it? Are we asking the right questions? That is maybe the questions. And for now, I welcome Gjalt Lindeboom of Seaqualize. Welcome, Gjalt. I think I have to congratulate you on winning the Offshore Wind Innovators Challenge by Mammoet last Friday. Congratulations. Oh, I cannot hear you. Wait.
Thank you very much.
I could read your lips. You said thank you, I saw it. Very good. So your company invented a balanced heave compensation system for the offshore installation of wind turbines. But to put it simply, every time you come up with a system that can lift heavier masses, it's already too small due to even bigger turbines. So what's your opinion on this discussion about standardization?
Absolutely.
I think. Wait a minute. I think the connection is not very good, but we really want to hear you. So maybe we can do something about that. The technical issue here. No, you have a very nice profile right now on our screen. Let's go on. Let's see if it can be restored, this connection. And because we are very interested, of course, what Gjalt has to say about this. Well, can we, I look at the, let's see if he's, let's talk about it a little bit more and see if Gjalt comes back.
A couple of more questions maybe.
Oh, that's good.
For Tamara. There's a question about the wind climate, whether that has an impact also on the conclusions of the report. And I know, of course, from reading the report that there were various wind climates considered. But maybe Tamara could elaborate on that.
I think Gjalt is back.
Okay.
So let's do that.
We'll part that
Gjalt is back. How is your connection, Gjalt? Are we connected?
I hope it's fine. I was in the meeting the whole time, but I understood that I dropped off.
Let's go. Let's go.
No, exactly. It's like the case in point, like you said. We just started to build something a year and a half ago, which was for a certain, which was, let's say, 600 tons. Then a year later, somebody comes and says, I'd like to have it for 700 tons. 2 months later, let's make it 750. And now we're developing one for 1,000 tons. And that is nothing new. I mean, we expect that growth to happen, but it really drains the resources. It's a case in point example of what was just explained in the table. So when we got the question from TKIs, are you for or against standardization? My humble gut reaction was, that's not a useful question. Who in his right mind is against standardization, or at least for a certain period, or for, just like David just said, for the maximum hub height, so we can all improve on the other important items. If turbine manufacturers like Siemens are now pleading already for some time, and installation contractors and equipment manufacturers like ourselves, for us, there's many reasons to be enthusiastic about it, especially if we standardize the maximum hub height. And now DNV has shown that the costs don't increase significantly anymore beyond a certain size. Then the interesting question is not so much, are you for or against this? It's rather, what's keeping us from doing it? And you've already touched a little bit upon that. But my question would be to elaborate a little bit on that further. And I think especially the leading force there would be the manufacturers. So my question to David would be, what is keeping us from actually doing that? And you already started to mention one item, and that is everybody's focusing on their own individual business case. But I was thinking, let's come up with some more reasons why. What would keep us from standardizing now? Is it that we're only just now plateauing, and that before this there was a significant cost increase to be made by increasing your turbine? Or do we underestimate the actual cost reduction, like Wouter was just saying, and then maybe DNV forgot to model some costs? Is there environmental reasoning that is more important to keep growth upwards? Is there contractual incentives for owners, for example, to have larger turbines that always deliver a high base load or more energy at lower wind speeds? Or is it supply side driven? Is it competitiveness by wind turbine generators that say, if we can build something bigger, and for our part of the business case that seems to be valuable, let's do it. And then competition just needs to follow. So I challenge the panel to share their thoughts and see if there's, now that consensus starts to form a little bit, to standardize turbines, or at least their sizes, what are the biggest hurdles that we need to overcome to get that done? Why aren't we getting there? I'm very interested, and thanks for the opportunity to share my thoughts.
For being here and asking that question. I think David will have to answer that in a minute. But let's first ask a Mentimeter question to the audience, and then we'll talk about this, David. Because I think the question is for the audience, tell us who you should make the first move towards standardization. And you can do that via menti.com, of course, with the code 163842220. Again, so if you answer that question, we'll ask David to answer the question is what is keeping us from standardizing?
Yeah, it's a nasty question, Gjalt. Now, my strong belief is that when you look to the history of wind, it started in the early 70s and with I call the Don Quixote period, where everybody was against. And then suddenly we realized that we need to focus on cost reduction. And this cost reduction has been so into our genes, into our DNA. We only have been focusing on cost out, reducing. And I think we just forgot that we have reached the point by the award of HKZ to Vattenfall that we have reached zero subsidy. And it still takes some time to shift focus from cost out, which we have received, to quality plus, and towards zero waste. So I think it's just about, we have been doing it so long and focusing so long on the cost out version and lowering the life cycle cost to prove that offshore wind could be competitive with, that we forgot that we have to change course now. And especially, I think because we have to make more speed. And this combination, making speed and not only building today what we will get in 20 years from now, but at the same time focusing on becoming fully sustainable or fully, let's say, zero waste is important. So to me, it's just like we have to become aware. And I'm very happy with DNV because they showed in a very, I think, profound report that it's also proven by the numbers, at least the assumptions they took, that is direction. Yeah, that's the right direction.
But I think also in a way maybe it's not fair to put all that burden on the wind turbine OEMs. It's a system question. We've seen that from the report. You saw some of the lines go up in cost and some of the lines go down in cost with increasing size. So if the perception is in fact that, say, less units installed is always better, then you're stuck in this frame. And so it's not only the question, I think, for the wind turbine OEMs, but it's a system question. Also for the developers to look at their business case, but also maybe for governments to look at how this system actually works.
So it's a more total...
Absolutely, yeah. So it's adding up all those costs that contribute to the LCOE eventually. And so it's not only the turbine, it's a very important element, clearly, but it's also all the other elements in there.
Look at the screen. Who should make the first step towards standardization of wind turbine sizes? Well, the EU, 33% is the highest, I think. The EU, no one. Just let the market do its work. Wind farm, what do you think about this result? Wouter?
Well, I'm in favor of the market myself, but it has to be within a sort of a setting of a very rough framework of constraints by the government. Because if you put too much regulation on the sector, it will stop innovation. If it is regulated by the government, it should be on a very conceptual level. I think maybe some specific incentives in tenders that are site specific. But the market, the sector needs to have room to innovate and to make the LCOE still go down, because I still think that that's for the benefit of society, but at the same time be able to extend lifetime, to work on circularity.
Yeah.
But the market should be able to do its work.
Yeah.
Yeah.
Oh, that's interesting. Mark, what framework should be given to standardization of wind turbines from an ecological point of view?
Well, as I said, the impacts can be very different depending on the design of a turbine, the size, mainly the height, and also the design of a wind farm. So when we're carrying out impact assessments prior to development, we can look at those using models. I think one thing, perhaps a different look at standardization, something that could be quite beneficial, and David suggested sort of wind energy and ecology or the environment doesn't have to always collide. There can be some benefits with sort of nature-inclusive designs. And one idea could be if you're producing turbines to have standard fittings in them, for example, for bats. It's been shown to be very effective to include audio deterrents. So if you had at standard positions on a mast where it's most effective, when we're trying to apply these to existing wind farms and suggest these, it's quite expensive, and boring holes in masts are probably it's a less popular option for a wind farm operator. And the same with, we're currently carrying out research to look at the sort of the effect of colouring one of the blades black to try and see if birds can then see the blades much better and avoid that. And again, carrying out these measures retrospectively can be quite expensive and not very practical. But if they were applied
Standard,
at the time of manufacture and across sort of a large scale, then the impacts can be much better assessed for one, and sort of the costs will come down. And it's including sort of nature in that early stage. So that's perhaps another.
That's of course interesting. I think you wanted to reply also on. Thank you, Mark. On Wouter just a minute ago.
Yeah, first I support the idea, of course, of more of the comment. I think that's great. You have to do it by design. But I think leaving it to the market, I think I look at it from a way, we also design a plot of site where you have to build your wind farm in. Why not extending those 2 dimensions to a 3rd dimension and defining a shoebox where you can just, you are constrained. So from 2 dimensions to 3 dimensions, it's not limiting, it's the only limit you have. But within this shoebox, you can do whatever you want, of course, limiting so much bird collision, so much impact on the sea mammals. But it's only one constraint, so you have the constraint in X and Y and in Z, and this is the only constraint you have. And with this, you are free to optimize, to do, but that's the only constraint you have. And I think if you look into the old days in the onshore wind, we also had a building permit with a maximum tip height. Even there you had a tip height, or let's say a rotor diameter and a hub height constraint. So it's, I think, the most easy.
Well, we have that box now in the tenders. So it's a tip height in the Netherlands. Yeah. And that's working fine. And I would support if you say, okay, we freeze that tip height for a larger area than HKW. We try to do that for Europe, but I agree. Then within that box, you have sufficient options to do your innovation and optimization.
But already we've mentioned, like in the Dutch situation, there may be such a shoebox. But if you look at, say, the international scale, it's quite different. Then you really need also the market maybe to do its work as well. And I would say that such an insight from the DNV report, that eventually it is just cheaper. There's an economic incentive.
If it's true what DNV is now sort of predicting, then economics is going to do its work, because then we're not going higher, because that doesn't pay anymore. Then we don't need a government.
No, that's true.
Then the market doesn't.
But at least there was this international dimension to the answers that you saw from Menti. That Dutch government 0% was the answer, and EU government was around 30 or something. But at least clearly this is an international problem.
No, that's true. And the only remark I can give is, can we wait until the European government has made their decision? And I think that we can't wait. And that's what you see in daily life. Global warming continues. So if you would like to make speed, And we know that offshore wind is, I think, 140 more carbon efficient than gas-fired power plants or coal-fired power plants. So we have to make speed. Yeah. And then, of course, you have to be maybe a little bit more firm or take ownership and just make it happen.
I think we can talk about this for hours, but if talking about making speed, I see the time running and running. So Bob, if there one last burning question you would want to ask Wouter, Mark or David, or conclusion, or because then we're going to wrap things up.
Yeah, so we've already touched, I think, on the if, and there's still maybe some further research is required, as Wouter also suggested, further insight into the actual cost. They're also very much site-dependent and internationally dependent. But still, there is a clear pattern, I think. Yeah, you could almost ask the same question we started off with again.
Yes.
Is it going to happen in the time frame, say, what was it, 2030, 2035?
What do you think?
Do you expect that?
That the standardization kicks in. That is, I'm very much in doubt because I don't see any government is going to make that the decision. It's very, very complicated. I think the Dutch government can do something in tenders, and they do. They've taken initiative to put these ecological criteria for Site 6 now, for example. That doesn't help the turbine, but you can put additional incentives in tenders to shift the focus from LCE to other important aspects. That can happen, but a wider sort of standardization sort of kick-started by governments, I don't see it happen.
But doubt is a good start for further, I think, research and investigation. So that's always an important criterion. David, you want to maybe you see it happening in that time?
Of course, I see it happening, and I think we have to continue this journey. And I think what is one of the big advantages of the Dutch market, we don't require any local content. So that will also differentiate us from the other markets. So if you want an important element in, we don't have any local content requirements. So that means that we can focus on other elements, bringing the next step.
Yeah, and we're out of time.
Yes, but of course.
And Mark, you want to still reflect on your expectations, whether this will happen, including also the ecological aspects to this?
I think if nature and wildlife can be included at an early stage, then that would be beneficial, and there's lots of opportunities to do that, I think.
Yeah. So in a way, it can also contribute then.
Okay, let's wrap things up because we're almost out of time. We ask 2 minutes for you. That's all we ask for you. Let's wrap things up. No conclusion, of course, no conclusive answer. That wasn't the goal of this edition, of course. Are you left with enough questions to continue the work at TKI Wind Op Zee?
Yeah, I think so.
The topic?
Yeah, absolutely. Yeah. So this is, I think, a bigger incentive even for innovation. And I think one of the conclusions that we draw, that there is a clear other path. I think a week ago we had maybe a different view on this. So the report really gave us insight into other options also for our innovation program. So I think that's important input. And of course, then you take a different route. So you start working on, say, optimization, but also working on things like for safer, for example, robotization can benefit from standardization, etc., etc. So all these routes, also circularity, David already mentioned that, I think is an important element, I think, in an innovation program that really benefits once things start to standardize. So there's even more work to be done.
And you weren't busy at all, weren't you? Do you have some other subjects you want to share with the audience? Yeah, well, maybe that's more beside the point of the discussion we had today. So it's looking forward to other events. There's a webinar, as I mentioned that briefly, that we are organizing together with the TKI Urban Energy. It's about weather systems. We live in a weather-driven energy system. That's on the 2nd of June. So please look at the website for more information about this. Then there's the Wind Day, of course, that is probably in all your calendars already, the 16th of June in IJmuiden, where we also have an innovation track there.
And of course, we have a full day together with Marin and the community of practice for the North Sea in the Blue Week event. And you'll be our host there as well, Sophie.
I will.
So please look at the agenda on our website to find all these interesting events.
Oh, yeah. So I think, thank you, Bob. That concludes our 10th edition of this TKI Wind Op Zee live. Thank you for your questions. If we haven't answered them, then we'll definitely get back to you. And we would love to know your appreciation of this edition, so that can happen via Mentimeter. I really want to thank all our guests in the studio today, David, Mark, Wouter, and of course Bob, and all our guests online, Tamara, Lars, and Ben, and of course Gjalt, for your participation on this edition. And I want to thank you, all of you at home, for watching, and we really hope to see you in September. We'll continue the TKI Wind Op Zee lives. Thank you very much, and goodbye.